I hope my screen is shared. So what we are going to do in this DC ACI course, so it is our 5-day course. Okay. So in day 1, we are going to discuss introducing Cisco ACI Fabric infrastructure and the basic concept, where we are discussing what is the ACI technology. Okay. And then today we are going to do 2 labs, the validate the fabric discovery and configuring NTP. So whatever lab you are getting, in that lab, you are not getting a chance to discover the fabric. Fabric is already discovered there. Okay, so you have to just validate, but I will show you the complete lab how to discover the fabric also. Then day 2, we are going to discuss about the logical construct of the ACI, where we are going to discuss how to create the access policies and how you configure the VPC into the ACI fabric. Then we are going to discuss describing the ACI policy logical model construct, enabling the layer 2 connectivity into the same EPG, means how you are going to communicate into the same EPG with same subnet or different subnet. Then day 3, we are going to discuss how you are going to communicate into the 2 different EPG. Okay, so when we are going to communicate in 2 different EPG, we need a contract. So how to apply the contract, those kind of stuff. Then we are going to discuss describing the ACI basic packet forwarding, how the ACI, our basic packet forwarding is happening into the ACI. Then enabling inter EPG layer 3 connectivity. Then compare the traffic forwarding method into the bridge domain. We have 2 options there, like flood and hardware proxy. By default option is the hardware proxy. So what is the difference when you choose the hardware proxy and what is the difference when you choose the flood option? Then in day 4, we are going to discuss the external network connectivity. In that, we are going to do 2 things, L2 out and L3 out. In our courseware, we have only the OSPF protocol. Okay, but if time allow, I can show you the EIGRP and BGP also. Then day 4, VMM integration. So here there will be the theoretical portion of the VMM integration, how you will integrate your virtual environment like VMware ESXi, Microsoft Hyper-V, Red Hat KVM, OpenStack, how you integrate with your ACI fabric. Then on day 4, we are going to discuss how we can integrate Epic with the VMware vCenter. Then describing the L4 to L7 integration and explore ACI management. So L4 to L7 integration, here we are going to discuss about the firewall, how we can integrate the firewall, but there is no lab here. But if you want to do the lab, okay, I can show you the lab with ASAV firewall. Okay. If someone is expert on Palo Alto and if you want to check like, okay, Palo Alto, how to integrate with the ACI fabric, you can do that thing. Then under this explaining the ACI management, we are going to discuss like, okay, how you can take the backup, how you can upgrade the fabric, how you can do the syslog, SNMP, how you can do the NTP, how you can do the AAA authentication, how you can do the RBAC, role-based access control, those kind of stuff. Okay. With respect to the breaks, so we will start 9 to max 9:15. Okay. We will take lunch break at 1 to 2. Then we will bind up 5 p.m. Okay. In between, if you want any break, you can just let me know. We can take 1 or 2 break, 5 to 10 minute break is there. Fine. Now, What is Cisco ACI? Application centric infrastructure. ACI is the SDN solution in Cisco. Okay. Now, in SDN, what we are doing? We are doing the configuration through the controller. We are doing configuration through controller. In ACI, our controller is Epic and devices are Nexus 9K. So through the Epic controller, you can manage only Nexus 9K. Next. ACI is partial SDN solution. Why I'm telling partial? Because if you compare this SDN solution with any another vendor, for example, like if I take the example of OpenStack. So in OpenStack controller is responsible for control plane as well as management plane. Management plane of the device. Whereas this Epic manage only management plane. Control plane is still available on the Nexus 9K devices. So that's why I'm telling it is what a partial SDN solution, because it is managing only the management plane of the Nexus 9K devices. Now, Cisco ACI technology work on.
What is the difference? Like again, in the OpenStack and this one, or are we going to cover in next slides?
No, this is the basic difference basically. Okay, in OpenStack controller, like they have their architecture like that way, like okay, they can manage the control plane and management plane of the particular device. But in Cisco ACI, Cisco designed the ACI like this way. You can just manage the management plane of the device. You can do the configuration on the controller, and then you push the configuration to the device. Once the configuration is reached to the device, it will generate their control plane based on that particular configuration. Okay. But in case of OpenStack, that OpenStack is generating everything like control plane and their management plane. Every visibility is there on the OpenStack controller.
Okay. So even the routing decisions and all the functions of control plane will be performed by OpenStack software, OpenStack controller only. Okay.
Right. But here we are doing everything. Let's say in case of Cisco ACI, if you talk about the routing, we are doing the routing. But what we are doing, we are creating the L3 out bunch of configuration, and then we are pushing that L3 out configuration to the respective device, which is connecting to my external device. Once the configuration is pushed there, then it will perform the control plane operations. Like, okay, like neighborship will form, okay, I learn the route or not. So those kind of stuff. In Cisco ACI, it will work on the spine and leaf architecture. Spine and leaf. Now, spine switches represent the backbone of the ACI fabric. connected to the leaf switch. So in spine to leaf architecture, spine to spine cannot be connected, leaf to leaf cannot be connected. Spine will be connected to the leaf switch only. And between spine to leaf, minimum connectivity will be 40 gig. Minimum. It can be 100 gig. It can be 400 gig. But minimum 40.
But we can have pair of leaf connected to each other like that. No? Leaf to leaf connection cannot happen. Like they will be sharing some common VTAP, but they can have connection in the connection.
No, leaf to leaf cannot be connected. Spine to spine cannot be connected. No, nothing will be connected to the spine switch with respect to the endpoint. Nothing will be connected to the spine switch with respect to the endpoint. There are some deployment scenario where you are connecting the devices to the spine switch. And which are the deployment? Multi-port, multi-site, and remote leaf. These are the deployment where we are connecting some IPN switches or IPN device with the spine. Otherwise, with respect to the endpoint connectivity, nothing we are connecting on the spine switch. Spine will be connecting to the leaf switch only. Okay.
Can you differentiate these two terms, multi-port and multi-site?
I will discuss. I will discuss that thing. Don't worry. It will come in further slide. I will show you separately. Okay. Next. Leaf. So with respect to the endpoint connectivity, our end user will be connected here. If we have any layer 2 switch which is connected with my Ethernet network, that will be connected to the leaf. If you have any firewall, that will be connected here. If you have any kind of load balancer, that will be connected here. If you have any router which is connecting to the external network, which is learning the external routes, so everything will be connected to the leaf switch only. Next, Epic. Epic is my controller. Unified point of the policy enforcement, health monitoring, and the management of the Cisco ACI fabric. So this is the controller who is managing that entire ACI fabric, not involved in data plane forwarding. Okay, so here you are doing the configuration and then you are pushing the configuration to the fabric. Now, resolving challenges of the traditional network with the Cisco ACI fabric. If we have normal traditional network, then we have this 3-tier architecture: access layer, distribution layer, and core layer. Whereas in Cisco ACI, we have the spine and leaf architecture, easy and simple topology. And in this, we are connecting leaf to spine connectivity. With respect to the redundancy purpose, we are taking minimum 2 spine in ACI topology. In spine and leaf topology, you are getting ECMP, equal cost multipathing. So if any link goes down, if any spine switch goes down, not issue, you are into still connectivity. Then here they are just showing a command show module. This command is check like how many modules you have inserted into the Nexus chassis. Let's say you have Nexus 9504 chassis. So how many modules you have inserted, how many supervisor module you inserted, how many fabric module you have inserted, how many line card you have inserted. Clear? Now, what is this fabric module, guys? Any idea about this fabric module? Anyone? What is fabric module?
SFP code?
No. Okay. Just a second. I have this chassis, the Nexus 9504. Okay, 9504 meaning is that 4 Ethernet modules. 4 modules. 1, 2, 3, 4. So these are my line card. We have 2 slots for the soup. And then we have this PSU, power supply unit. Okay. One line card represent a switch which contain the ports. Okay. Let's suppose if any PC is here and if any PC is here, PC1, PC2. If you want to communicate PC1 to PC2, how the traffic will go? So as I told you, like, okay, one line card represent one switch. So logically it will be switch 2. Fine. In normal traditional network communication, we need this connectivity. Then only the traffic can reach PC1 to PC2, right? Now we insert these line card inside our chassis. So how that backplane connectivity will form? So on the Nexus devices, on the Nexus chassis switches, we are inserting one module which is known as fabric module. That fabric module will provide the backplane connectivity of my all the line card and with the soup engine. Clear? It is a additional component on the Cisco Nexus chassis. Clear my point? So if you go to the rear chassis of the Nexus box, so you will get fan. You have to remove the fan, and after that you will get a slot to insert the fabric. So that's why, like on these Nexus devices, we give the name of the fabric because we put our line card like this way and fabric module like vertical. So it looked like a fabric. Fine. Next. In normal traditional network, okay, we have the STP. Okay, to remove the loop. But in ACI fabric, we are not connecting spine to spine. We are not connecting leaf to leaf. Okay, when you make this ACI fabric connectivity, by default in the spinal leaf, there is a infra VRF. Okay, and inside this infra VRF, there is no STP required. So all my ports are under open state, or you can say the active state. There will be no blocking state. That's why we are getting ECMP, equal cost multipathing. So in ACI fabric, the STP is by default disabled inside the ACI fabric. But if you have any layer 2 switches connecting downstream your leaf switches, here the STP can work. Next. In my traditional network, on the switches, the basic security is based on the VLAN. Based on the VLAN meaning is that if I have this particular switch and there are two PC which belongs to the two different VLAN, let's say VLAN 10, VLAN 20. So by default, they will not communicate. Okay, if they belongs to the same VLAN, they can communicate. If they belongs to the different VLAN, they will not communicate by default. If you want, then you have to do the inter-VLAN routing. But in ACI, security is not based on the VLAN. Security is based on the EPG, endpoint group. Now, what is this EPG? It is basically container for endpoint, or you can say our users. Now, if the endpoint belongs to the same EPG, they can communicate by default, whether they belongs to the different IP subnet or same IP subnet, different VLAN or same VLAN, they can communicate. But if the endpoint belongs to two different EPG, they will not communicate by default. If you want to communicate EPG1 to EPG2, you need a contract. So inside the contract, basically you are defining, okay, what protocol is allowed between the EPG1 and EPG2. So it is kind of ACL between these two EPGs. Clear, guys? Any question here?
Sir, actually one thing, this part is okay, but can you like again in the beginning itself, like for the group, understanding complete diagram like tenant and then this thing contract, access policies, and then these things where the epic
Yeah.
controller will sit and ultimately the EPG group, for example, web app DB segment kind of thing, and the access policies. So broad topology diagram of a standard ACI implementation. I think so. In that case, it will be better to understand for group.
Hello, I'm connected. Hello, guys. Are you getting my voice?
Yes, yes.
Okay. So someone is asking the question. I'm not getting the voice at that time. Can you repeat the question?
No, actually, I was asking this thing, broad topology, if you can just draw like what all components are there. For example, in the case tenant, then we have Epic, we have, this underlying hardware is there. We have, contracts, access policies pushing, and the EPG, finally EPG where it will be sitting. So, and VRF kind of thing. So if you can just draw the broad topology, then the complete PPT will be better. We will be better to understand this thing.
Right. I will do the same thing. Like I'm just going to cover just the basic slide. Then I will make a separate topology, and whatever thing I'm discussing, I will make a separate picture and draw each and everything. Like what are the physical configuration component, like VLAN pool, domain, AEP, all things. I will put it separately. Don't worry. Next. If we have normal traditional switches, if we want to deploy any configuration there, we have to access the devices one by one, and then we are doing the configuration. But in ACI Fabric, we have the controller. We are accessing the controller. Okay, we are doing the configuration on the controller, and then we are pushing the configuration to the devices. So at that time, we are not directly interacting with the devices. We are interacting with the epic. Now, if this epic want to forward any configuration to the leaf devices or the spine devices, these devices must be registered on the controller. Next. So on iOS devices, you are doing the static configuration, no automation. But here right now in the ACI Fabric, you can do the automation. Now, in the traditional network, we have the storage team, we have the server team, then we have the a team who is managing the virtual environment, right? So you have to coordinate between the network and the server team. But in the ACI Fabric, you can easily integrate your VMware, Hyper-V, OpenStack, Kubernetes, OpenShift, UCS Manager. You can easily integrate with the ACI Fabric. Okay. So if we talk about the benefits again, so in the ACI benefit, what we are getting? First benefit, centralized management.
Rakesh, I
You are
have one question.
Yeah.
What additional benefit I am getting through controller which I am not able to get through DCNM?
Okay.
Because through DCNM also I can push configuration centrally, or I think schedule also.
Right. So DCNM is the configuration, like GUI configuration tool through which you can manage your Nexus devices and storage devices, as well as some iOS devices you can manage, right? But through the DCNM, right, you cannot do all those functions. Let's say you cannot do integration with the any kind of hypervisor. Okay, let's say VM, you want to integrate with the ESXi, you want to integrate with the Hyper-V, you want to integrate with Red Hat KVM. Can you do with that thing, DCNM?
No. But
right?
integration.
So there are some,
yeah.
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 There are some advanced stuff which we cannot do through the DCNM software. Okay. DCNM we are using basically right now for the storage perspective. Okay. You can do easily like your VXLAN, VPC through the DCNM. So with respect to the NX OS operation, you can use the DCNM tool. With respect to the SAN OS, you can use the DCNM tool. Okay, in NX OS, let's say if I'm talking about the Epic. So Epic is designed specifically for the Nexus 9K and for the ACI mode. Nexus 9K are the devices who can operate in two modes, NXOS and the ACI. So if my devices are under the NXOS and I want to configure the things graphically, then we have this tool, DCNM. And here, NXOS, that will be not limited to my 9K. Here, DCNM can manage your 9K NXOS, 7K, 6K, 5K, 3K. And your 2K fax devices also. You can configure fax. If I go with the SAN OS, you can configure like basic storage operation, your zoning, right? IVR. So those kind of Nexus, NXOS feature and SAN OS feature, if you want to do, then DCNM is the tool. But through the DCNM, you cannot manage or operate the ACI functionality. Clear the difference. DCNM is for the NXOS and SAN-OS. Any question here?
So when I say I can integrate ACI with the virtualization, what does it mean?
Okay, cool. Meaning
Does
is
it?
that like,
Yeah.
meaning is that like, okay, in ACI, our endpoint can be the physical endpoint and can be the logical endpoint, like virtual endpoint. If I talk about the physical endpoint, that means the end user is directly connected with the ACI fabric, directly connected with the leaf switches. But if I have this kind of setup, on the leaf switch, I have connected a server. In that server, I have installed ESXi. Inside the ESXi, I have thousands of VM. Those VM want to be part of my ACI fabric, right? So that I'm telling like, okay, for those VM, you have to integrate your hypervisor with the ACI fabric. That is known as basically nothing VMM integration. If I draw a picture, just a second, there are two things. This is my spine. Leaf. So this is my physical endpoint. Second option, Leaf is connected with a server. In that I have installed the hypervisor. And now these are the VM. On this Leaf, I have connected with the router and that router is connecting with the external world. If these VM want to reach these external network, so these VM must be the part of my ACI fabric. My ACI fabric should understand these endpoint. Then only this ACI will forward the traffic to the external world, right? So for this particular environment, we have to integrate VMware ESXi with ACI fabric. This thing is known as VMM integration.
But Rakesh, this is what happens in the normal leaf spine architecture also. I terminate my ESXi host directly to the leaf switches. Then what is the difference? And on virtualization platform, I create the distributed virtual switches. Correct. And
Correct.
through the physical switches of the ESXi host, I terminate it directly to the leaf switch. So that is also integration of ESXi with my leaf switches. So what is the difference when I say that I will integrate ESXi with ACI?
Okay.
Means am I installing something on ESXi or what
No,
is
no,
the
no, no. You
different
are
kind
not.
of
No,
connectivity?
no. Okay. I will discuss. That is our last topic actually. Okay, but just for your clarity, at that time you are creating here DVS, right?
Yes.
But if you are creating the DVS on the ESXi, in that case, this DVS is not aware this ACI fabric because that you created inside your ESXi. So when you are integrating your VMware with the ESXi, here you are creating the EPG. What I want, this VM, let's say I have two EPG, app EPG, web EPG. I want to put VM1 and VM2. This should be the part of app EPG. This should be the part of web EPG. Okay. So when you integrate this EPG with your VMM domain, then it will create automatically DVS here. DVS port group, sorry. When you integrate your VMware with the ACI fabric, it will create this DVS automatically, and to connect the VMs on the DVS, you need the port group. So when you integrate the EPG with your VMM domain, then automatically on the DVS, there will be port group created where you can connect the VMs. So we are not creating any DVS on the ESXi. We are not creating the port group on the ESXi. Everything will be coming through my ACI fabric. Fine. I will discuss more completely from the scratch when we are doing this topic like, okay, VMM integration. Okay. So what we discuss, ACI benefit, centralized management. You can manage all your Nexus 9K devices through one controller. Second point. ACI is policy-based model. Policy-based model meaning is that if I have a normal layer 2 switch, here if I connected APC, on that interface, let's say FA 0/1, I have to configure, let's say, speed. I have to configure something about CDP. I have to configure something about LLDP. I have to configure something about LSEP, BPDU guard, those kind of things. So I have to log into the switch and going into that particular interface, and then I'm running all these commands. But in ACI, whatever configuration you want to do, you have to create a policy for that. So for the speed, you are creating link level policy. For the CDP, you are creating a separate policy. For LLDP, you are creating a separate policy. For LSEP, you are creating a separate policy. Whatever configuration you want to do, you are creating a policy for that. Then you will call the policy into the policy group. Then you are calling the policy group into the interface profile. Then you are calling this interface profile to the switch profile. So policy is what configuration you want to do. Directly policy you cannot apply to the particular port. You have to call policy into the policy group. Then you are calling the policy group into the interface profile. So into the interface profile, you are doing two things. You are defining interface, on which interface you are going to apply that policy. And then you are applying that policy group. In switch profile, you are defining this particular interface present on which switch. Because when you are registering your spinal leaf devices on the controller have all the information about your leaf 101, 102, 103, all the switches. So this interface 1/1 or 0/1 present on which leaf. For that, you have to create the switch profile where you are defining the switch and you are applying the interface profile. So this is the way of the configuration, how you are doing the configuration into the ACI fabric. Okay, I will discuss this entire flow from beginning to end, right? Once again, when we reach to the physical construct and the logical construct. Okay, next. Stateless solution. Why I'm telling a stateless solution? Because the Nexus 9K devices, they are stateless in nature in the ACI mode. So by default, on those ports, only LLDP is enabled. Rest of all the configuration is disabled. You are doing the configuration through the controller. Okay. Automation and integration. If you know any kind of automation tool, for example, like Puppet, Chef, Ansible, you can easily do the automation from those automation servers. Integration, you can easily integrate your firewall, load balancer, any kind of virtualized environment. For example, like ESXi, Hyper-V, Red Hat KVM, OpenStack, OpenShift, right? Kubernetes. So you can integrate with the ACI fabric. Security is based on EPG. Endpoint into the same EPG can communicate with each other, whether they belong to the same subnet or different subnet. Member belonging to the two different EPG cannot communicate by default. If you want to communicate, then you need a contract. Transparent health score. Transparent health score meaning is that like on the Epic GUI, it will give you the health of your devices, health of your fabric, health of your controller, and health of your configuration. If your tenant health is, let's say, 50%, 40%, that means there is some configuration issue on that tenant configuration. Okay, if your tenant health score is 99%, 98%, 100%, that means the configuration is correct. Okay. If your health score of your spine and leaf devices are down, that means there is some issue going on our spine and leaf devices. So these are the benefits. Next. Then we discuss about ACI design. So we discussed that thing. Spine to spine can't be connected. Leaf to leaf can't be connected. Spine will be connected. Leaf only. Leaf will be connected. Rest of network. Controller will be connected to leaf switch only. One controller can be connected to max 2 leaf switches. Controller to leaf connectivity will be 10 gig. And between spine to leaf connectivity will be minimum 40 gig. It can be 100 gig, it can be 400 gig. So these are some design rules of your ACI fabric. ACI topology and hardware. So hardware is what? My Nexus 9K. In the Nexus 9K, we have 3 series. 9200, 9300, 9500. 9200 is pure NXOS. So in 9200, we cannot run ACI fabric. 93 and 95 are the two models where you can run NXOS and ACI. So on the device, you can put both the operating system, but you have to define, okay, which operating system you want to run on that device. No. So when this ACI come into the picture, so Cisco design like that way, 9300 I will use as a leaf and 9500 I will use as a spine. But sometimes customer want a cheaper solution. So right now in 9300, we have spine as well as the leaf model. Okay, 95 is the chassis based solution. So inside chassis based solution, what kind of line card you are putting? That define, okay, this switch will behave as a spine or leaf. Okay, so basically on the 9300 and on 9500 line card, there will be a ASIC, a chip, which define that switch can become a leaf or spine. In the first generation, there are two type of ASIC. One is ALE and another one is ASE. Application leaf engine, application spine engine. So if any device which is having this particular ASIC, that will behave as a leaf. If any device which is having this particular ASIC, ASE, application spine engine, that will behave as a spine. Clear this thing? Any question here, guys? Okay. So in case of ACI topology, minimum 2 spine switches you needed. Why? If you have only one spine, if you have one spine and that spine goes down, then there is no connectivity between the leaf to leaf because they are connecting through the spine switch. So minimum 2 spine we needed for the redundancy purpose. If any link goes down, not an issue. If the spine goes down, not an issue. Leaf switches never connect to each other. So leaf to leaf cannot be connected. And device is only connected to the leaf switches. So whatever our end points, those will be connecting to my leaf switches only. High speed IP fabric meaning is that here minimum connectivity 40 gig. It can be 100 gig. It can be 400 gig. Spine and leaf topology benefits. Simple and consistent topology. Scalability for the connectivity and the bandwidth. Symmetry for optimization, forwarding behavior. Least cost design for high bandwidth. So all these benefits we are talking in our spine and leaf topology. Okay, then. ISIS infrastructure routing. Protocol used in ACI fabric. First one, ISIS, VXLAN. 2, OPFlex. Then LLDP, 20 gig CP, MPBGB. These are the protocol who are running in my ACI fabric by default. No need to enable it. Okay, so now I'm going to discuss one by one. First protocol is ISIS, intermediate system to intermediate system. Basically, ISIS is a routing protocol. Okay, layer 3 routing protocol. But in ACI fabric, ISIS protocol is not doing any kind of routing. ISIS protocol is used only for infrastructure management only. Infrastructure management only. Now, what is that meaning? Meaning is that when on the controller, when we register all spine and leaf switches, ISIS build topology database of spine and leaf switches. So ISIS just give that information how the spine and leaf devices are connected with each other. ISIS is not providing any kind of routing. It is only for infrastructure management. Clear, guys? Any question?
So it's okay.
Second protocol we have VXLAN. VXLAN. VXLAN by default enabled in our ACI fabric. No need to configure any kind of tunnel configuration. Okay. Now, when you are forwarding the traffic from leaf to leaf, any endpoint which is connected on leaf 1, any endpoint connected on leaf 2 or leaf 3. So when first time communication happen, then it will form automatically a VXLAN tunnel. Okay. To form a VXLAN tunnel, we need a tap IP address. Okay. We need a multicast IP address. Okay. That configuration we are doing when we are doing the initial configuration. Okay, we are defining here a tab pool, we are defining here a infra VLAN ID, we are defining a multicast address range, right, which is used for the multicast, which is used for the VXLAN. Okay, so by default VXLAN is enabled on our ACI fabric. Now, if you read about the VXLAN can be deployed into the 3 ways: head and replication, flood and learn, and in MPBGP EVPN mode. So the VXLAN is running inside the ACI fabric in MPBGP EVPN mode. So that's what this particular protocol is also used. But in ACI fabric, this particular protocol will be used when you are doing L3 out. Will be used in L3 out. When you are exchanging the routes from one leaf to another leaf. Now, then we have a protocol COOP.
In this case, just on the VX line, I have one question. The tap endpoints will be what? The leaf and the spine, or what?
I will explain that thing. Once I will discuss the fabric discovery and the initial configuration of my controller, then I will discuss all the things. Don't worry. I will explain that thing after this. COOP. Now, let's suppose we have these two endpoints. MAC address is AAE 10.0.0.1. MAC address is BBB and 10.0.0.2. Fine. Leaf 101, leaf 102. So we want to communicate endpoint 1 to endpoint 2. This is a switch fabric. It will forward the frame based on the MAC address only. Okay. So on my leaf devices, there are two tables, LST and GST. Local station table, global station table. Okay. So this particular leaf switch will learn this address through the ARP, or when it will do the first communication, it will put that entry into the local station table. Whatever interface is there, let's say 1/1. Okay. Whatever VLAN is there, then MAC address is AAA. Same way, 1/2, let's say it is connected to BBB. Now, leaf to leaf, there is no connectivity, right? So they will not get this MAC address directly. So leaf 1 is not aware about BBB, and leaf 102 is not aware about AAA right now. In ACI fabric, okay, there is an option bridge domain. Under the bridge domain, there are two options. Hardware proxy, which is the by default option, and second one is the flood. This is the by default option. Now, there is a COOP protocol which is working between the leaf and spine. So whatever information is there on my LST, each switch will share this LST information to the spine with the help of COOP protocol. So this spine will take this entry, okay, leaf 101 interface 1/1 and MAC address is, let's suppose, AAA. Leaf 102 1/2 BBB. So spine will get all the leaf information, all the LST information with the help of COOP protocol, Council of Oracle protocol. And spine will put that information in their database, and that database is known as PST, proxy station table. Okay, but right now there is no information in my GST, global station table. Now, so when you are communicating PC1 to PC2, endpoint 1 to endpoint 2, then it is going to the ACI fabric. The traffic, till now, the traffic is what? My Ethernet traffic. Okay, ACI is running where? Between leaf and spine switches. So when the traffic is hitting to my ACI fabric, this ACI will check what is the bridge domain option. It is hardware proxy or it will be flood. Firstly, it will check that thing. Okay, in my LST or in my GST, is there any information about the destination MAC? There is no information. Then it will check the BD option, bridge domain option. The bridge domain option, it will check, okay, it is the hardware proxy or it's flood. Hardware proxy will be the by default option selected. So hardware proxy meaning is that if you are not finding any information about the destination MAC, then forward that information to the spine switch, because spine is having all the information about all the endpoints. Now, when the request is reaching here, this leaf 102 knows about BBB. So it will check the PST. Now, through that, it will get that information. Okay, if you want to reach BBB, you have to forward the traffic to leaf 102. So the traffic will be forwarded here. When the traffic is reaching here, it get to know that thing like, okay, BBB is directly connected with me, reaching, and it will give the reply. Once this reply is reaching here, automatically they will form a VXLAN tunnel. So next traffic, okay, once they will form the VXLAN tunnel, they will put that entry into my GST. Let's say tunnel 8. Okay, so next communication, when it is communicating again endpoint 1 to endpoint 2, again it will check LST. No information, but right now in my GST there is information. You can reach BBB via the tunnel 8. So the traffic is directly going like this way at that time. Okay, so the COOP protocol is used to forward the LST information of the leaf to the spine, but COOP is not doing this reverse task, means spine to leaf, it is not forwarding any information. So COOP is used between the leaf to spine only. Clear my point? Any question, guys?
Can you repeat the full form of GST PST?
Okay, PST, proxy station table. GST, global station table. LST, local station table.
Can you explain a flood mechanism?
Flood, I will discuss that thing. We have this activity, 7th, discovery number 7. I will discuss that thing. We have the complete topic on this, hardware proxy and flood, discovery number 7. Flood meaning is that flood the traffic, don't forward the traffic to the spine, but flood within the bridge domain. In our ACI fabric, we can have multiple bridge domains. Okay.
Okay.
All good till now? Next protocol is OP flex.
What is this epic?
Controller.
Okay.
Okay. So on the management PC, we are accessing the controller, HTTPS and whatever epic IP.
Before you actually continue with this, on the last slides, you have said that this controller will be connected to maximum 2 leaves.
Yeah.
So you were talking about the instances of controller, or
One controller can be connected with a two leaf.
when I you say controller, it's a hardware appliance or it's something virtual?
It's a hardware appliance.
So that means if I have six leaf switches, I will need three hardware appliance controllers.
Right. But one controller is enough to discover the entire fabric. It will be not like that. If you have 10 leaf switches, you have to put multiple controller. No, one controller is enough for discovering the entire topology. Okay,
So
but just
that
for the
that means
redundancy, purpose, we are putting minimum 3 controller for the cluster.
okay.
Okay. After this, like once I will complete these protocol, then I will reach to the epic initial configuration and all those things. Then I will discuss this thing. Okay. When I will discuss the fabric discovery, I will come to that point. Okay. Controller. Sorry. Then we are accessing this thing, controller. And here we are doing the configuration under the GUI. Okay. Then we are forwarding this configuration, this GUI configuration to the respective device. Clear? So between controller and leaf devices or the spine devices, there is a protocol OP-Flex. OP-Flex agent is by default running on my spine and leaf devices. Now, what this OP-Flex is doing, OP-Flex convert GUI configuration into relevant CLI configuration and apply to interface. Okay, so the OP-Flex protocol convert the GUI configuration into the relevant CLI configuration. Next protocol we have LLDP, Link Layer Discovery Protocol. By default, LLDP is enabled on all interface of spine and leaf and controllers. Used to discover fabric. Used to discover the fabric. Then we have a protocol DHCP. Okay, we know that thing DHCP is used to assign the IP address to the clients. So when devices registered on Epic, they will get tap IP from controller. Okay, so that means DHCP is by default enabled. Enabled on controller. Okay, now what is this tap IP address? All these things we are discussing when I'm discussing the fabric discovery process. Any confusion in OP-Flex, DHCP, and LLDP, guys, till now? Okay. Next is MPBGP. Let's suppose if we have this kind of configuration, spine, leaf 101, leaf 102. On leaf 102, I have a router. That router is connecting to the internet or some external network. if you want to receive, this is my ACI fabric. Okay. Now, if you want to receive here, let's say 20, 21, 22, these routes are there. After this R1. If my endpoint want to reach 20, 21, 22, these routes should enter in my ACI fabric. So for that, what we have to do? We have to do routing. And routing in the ACI is known as L3 out. Okay. So let's suppose you have configured L3 out on leaf 102, okay, with R1. So what will happen? These routes will coming to the ACI fabric and on my leaf 102. The endpoint which is connected on the leaf 102, they can reach here. There will be no issue. They can easily reach because this leaf 102 knows all the routes. Between leaf 101 and 102, they don't have any connectivity. They are connecting with the spine switch. And by default, BGP is also running on the spine and leaf. Automatically one AS number will be there and they have the BGP neighborship and that will be neighborship with IBGP. So if you remember in IBGP, there is a split horizon rule. Correct, guys? Yes, who will tell me BGP split horizon rule? Anyone? BGP split horizon rule, guys. Who will tell?
It's basically for preventing loops, network loops.
No. R1 is connected with R2, connected with R3. All these are under, let's suppose, AS100. Fine.
This is
If
basically for IBGP will not update the traffic to another IBGP.
Correct. So here is the same thing. These routes are coming to the leaf 102. That means to this. It can share to R2. The routes can go to the spine. But this spine will not forward this route to the R1. Clear? Now, what is the solution for this? In this scenario, what is the solution?
Default originate.
Default originate.
Route reflector.
Yes. So at that time, whatever spine you have in your production environment, whether you have 1, 2, 3, 4, 5, all the spine switches you have to define as a route reflector. Clear my point? Once you define, so those routes can be reached. Now this endpoint can communicate to external network. So this is what my MPBGP. In MPBGP, nothing you have to define. MPBGP, BGP, IBGP is running in your network, and you have to, like, with respect to the MPBGP configuration, you have to just define a route reflector. Route reflector is not configured.
And this will be route reflector will be at the spine.
Right.
So whatever number of spines we have to define each and every spine as a route reflector.
Correct. We will see that thing, like whatever case I have mentioned here, the same I will make it on L3 out and I will show you that thing. Clear, guys? So these are the protocol which is used into the ACI fabric, and no need to enable it. These protocols are by default enabled. Now let's come to here. So ISIS fabric. ISIS fabric infrastructure routing. ISIS is responsible for infrastructure connectivity in the ACI fabric. It provides the IP reachability among the tap IP addresses. Okay, so whatever device will be registered on the controller, each and every device will get one tap IP address. Tap IP. Okay. Now, anyone configure the VXLAN, guys? From you? Anyone have configured the VXLAN?
Yes, yes.
Okay. So in the VXLAN, there is a mandatory thing. You have to configure the loopback 0, right?
Correct.
Okay. So same way, when you are registering your devices on the controller, each and every device, when the device will be registered, automatically they will get a tap IP address, and that IP address will create automatically interface loopback 0 on the device, and that tap IP address will be assigned there because the VXLAN will be formed automatically, right? So VXLAN tunnel need the loopback 0 IP address, and whatever tap IP address all the devices are getting, the tap IP address will be used for tunnel source and destination. That tap IP address will be not used for any another communication. Okay. Automatically deployed, no user intervention is required, no ISIS knowledge is required. So once you register your devices between this spine and leaf, ISIS protocol by default enabled. And it is only for the infrastructure management. Just keep that database like, okay, how the spine and leaf devices are connected.
I have one question in this case, like the first point I was referring to. Again, you have talked about, there is no two leaf will not be interconnected. So in our environment, we have leaves connected, but I'm getting this question. If you are saying this thing that no two leaves will be connected, so how you are going to ensure high availability for a server kind of thing which is getting connected to, for example, in the case if both are not going to connect interconnected, then you are going to terminate the server connection on a single leaf, and if that single leaf is down, then your server is isolated. In this case,
If
in our environment, two leaves are interconnected and are sharing common VTAP IP.
one second. If we have any server, so we can have two options there, like server connectivity. I can take a L2 switch where my server is connected. Okay. This I can say case one. Second case, I can do this thing. I can connect server directly to the multiples leaf. So in both the cases, we have to configure VPC. Here, I will configure the VPC with my layer 2 switch. Okay. Then here I can do the same VPC configuration, but this time here I will do what? NIC teaming. So
But for
now if
example,
one leaf,
I don't have any option of NIC teaming here on the server side. How would I ensure like, okay, my connectivity will continue to work?
NIC teaming option will be there on every server.
Okay.
NIC teaming
Okay,
option will be getting.
what I'm saying in this case, okay, let me check my environment. I think we have leaf connected and they are sharing common VTAP IP. Is there any difference between a DCNM deployed L2 fabric and ACI deployed fabric? like this constraint of interconnection of two leaves that is being told by you, like two leaves cannot be interconnected.
I told you that thing. See, DCNM tool is used for managing NXOS. Okay. If your devices are running into the NXOS, I can connect that thing. Not a issue. But
Okay.
if I'm using ACI, in that case, I don't require this connectivity.
Okay. That's correct then.
Okay.
Yeah. Moving.
And we already discussed that thing. DCNM is a management server, or you can say a controller for managing NXOS or SAN OS. Again, the DCNM is coming for two variant, like for the LAN and for the SAN client and LAN client. So this is used for managing this. But if you want to manage the ACI, they have make a separate controller, and that is what Epic.
Okay. Yeah. Fine.
Okay, one question, Vakul. Can you explain more about the VXLAN and VTAP? Sure, Vakul. I will give you a brief of the VXLAN. Let me just complete this fabric discovery. Okay, and then I will take a small session on the VXLAN.
Okay.
So what we're talking about right now? Okay, so we discussed that thing. Okay, endpoint forwarding across the leaf. I already discussed that point. Okay, now controller will be there, but I'm not drawing the controller right now. Spine, leaf 101, leaf 102. This is my ACI fabric. Now, A, B. Leaf to endpoint, the connection is what? Ethernet. So when the PC will send the traffic is Ethernet. When the traffic is hitting to my leaf devices, on the leaf devices, these devices are registered on my Epic. So once they registered, that means all those protocols which we discussed, like VXLAN, ISIS, COOP protocol, okay, MPBGP. Okay, these protocol will be enabled in my ACI fabric. So under the VXLAN, we have a term which is VTAP, VXLAN tunnel endpoint. So VTAP is that device where we are going to configure the VXLAN, which is basically responsible for encapsulating and de-encapsulation of our packets. So when the traffic is reaching to this leaf, this Ethernet header, Ethernet traffic will be encapsulating into the VXLAN and forwarding into the ACI fabric. So our traffic is going through our VXLAN. Okay, the traffic is reaching here. So this leaf is doing what? It is encapsulating my traffic. So when the same traffic is coming here, VXLAN and the Ethernet, it will remove the VXLAN header and forwarding the Ethernet frame to the destination. Okay, and how it is forwarding the traffic, that we already discussed through the LST and through the PST. Okay, so they will check the BD option, it is hardware proxy or it is a flood. If it is a hardware proxy, then they are forwarding the traffic to the spine and then they are reaching to the destination.
In this key is this VLAN to VXLAN mapping, or some this VXLAN encapsulation will be decided based on the VLAN to VXLAN mapping which is configured on this leaf node, correct?
Right.
Okay.
So here. So endpoint are identified by the IP or the MAC address, means these VM or it can be the physical PC. Endpoint location is specified by the TAP IP address. Each and every leaf and spine device, they will receive one TAP IP address, which is the TAP IP address will be the source and destination of the VXLAN tunnel. Forwarding is based on the TAP IP address in the VXLAN encapsulation. Okay, as I already mentioned, like, okay, the TAP IP address will be the tunnel source and destination IP address. If the ingress leaf is not aware about the destination endpoint, the COOP on each spine knows the mapping of endpoint and the TAP. Whatever spine devices we have, they will get the information about each and every endpoint, and they will put that entry into the PST, proxy station table. And this proxy station table database will be synchronized among all the spine devices. Okay, they have the same database. So that's what, if one of the spine goes down, not an issue. We have the another spine and there will be no impact on our traffic. Clear? Okay. Deployment option, multi-tier and multi-port. Multi-tier is what? Single cluster, okay, a solution that corresponds to the core aggregation access layer architecture. Additional tier 2 leaf is connecting to host and the server on the downlink ports and the connectivity to the tier 1 leaf aggregation. So multi-tier, you can spine. This kind of deployment also you can do. That is what multi-layer. Here we have the leaf, here we have the leaf. Okay, but that is under one particular network. Second solution we have multi-pod. Multi-pod is what? If you have big ACI infrastructure, okay, let's say in your organization you have two buildings. So you have ACI port 1 here, ACI 2. We have two ACI port now. Spine, leaf 1, leaf 2, leaf 3, leaf 4, leaf 5. Okay. So currently, if you are accessing this particular epic, so you are managing only these spinal leaf. If you access this epic, you are managing only these devices. In multi-pod, what we can do, okay, so this cloud will be providing the L3 connectivity basically. Okay, so once we have the reachability from spine to spine via this L3 connectivity, we can define this multipod. Under the multipod, what we can do, we can make a cluster of these three controllers. And then through the central point, we can manage this complete infrastructure. So multipod meaning is that like, okay, we have two ACI fabric in the same location, same site. And we make the cluster of these two pods. One solution we have multi-site. Now, this ACI is in, let's suppose, Delhi. This is in Bangalore. So through the IP connectivity, we can reach. At that time, we are using some IPN switches. IPN devices. IPN can be your Nexus 7K, can be your ASR router. Basically, the link will be 10 gig. And these IPN devices are just providing the routing connectivity so that I can reach from this point to this point.
Rakesh, what is L3 connectivity here on the top?
This one is the internet connectivity. No?
Okay.
This
okay.
can be
So
like
spine switches are directly connected to internet. Is it?
No, through the IPN devices. Here it can be Nexus 7K, it can be the ASR routers.
Okay.
That ASR router connecting to the internet. Clear?
But we don't connect spine directly, na? We will connect leaf switches.
I told you there are some.
Yeah.
No.
Yeah,
At that time, I told you that thing. There are some deployment scenario, multi-port, multi-site, and remote leaf, where we are connecting some connections, some devices with the spine. Otherwise, with respect to the LAN connectivity, everything will be connecting to the leaf only. This is for connecting the branches. If you want to manage Delhi and Bangalore branch from one single point of connectivity, so we need the reachability between them. So this IPN is just providing the layer 3 connectivity between the two sites, Delhi to Bangalore.
Okay.
Okay. Plus, in the multi-site, you need one more application which is known as MSO, multi-site orchestrator. Okay. This is an application which is used to manage all these sites from one single point. Okay. Recently, Cisco renamed this, I think so, Nexus dashboard. They have renamed this particular application Nexus dashboard. Okay. So if we are going to connect to branches, to ACI branches which are in two different cities, then the solution is known as multi-site. Next. In Cisco, we have one more solution which is known as vPod, virtual pod solution. So this is for virtualized environment. Okay, virtualized environment, for example, in this spine and leaf are virtual. Epic is also virtual. So this is for the virtualized environment. For example, like your ESXi, Microsoft Hyper-V, Red Hat KVM, OpenStack. Okay, in this we are using one more kind of switch which is known as AVE, Application Virtual Edge. Okay, so this AVE is a, you can say, a switch which connects VM. Which connects VM. So we have this particular solution also for the virtual environment. Then we have one solution which is known as a remote leaf. Let's take the same example. Here we have one ACI fabric. Okay, ACI 1. Let's suppose Delhi. Or maybe I have that set up into one building, and another building I have only the leaf. I don't have the spine there. So I can connect directly this particular thing with the spine, and between them I need the layer 3 reachability. So if we have this kind of network, that is known as the remote leaf connectivity. Remote leaf architecture. So these are the ACI deployments. Clear, guys? After that, we have to discuss epic initial configuration. Guys, let's take a small break and then we will do this initial configuration, and I will show you one small lab activity. Fine.
Okay.
So right now 11:15, right? So max to max, like 10 minutes, fine? Or 15 minutes?
Yes, yes.
It's up to you.
Okay.
It's up.
25.
Okay, fine. Guys, I'm back.
Yes.
Thanks. So I hope everyone is back, right?
Yes.
Epic initial configuration. So if you have the ACI fabric, then in the ACI fabric, first device which we have to configure, that is Epic. So this will be my physical connectivity. But when you firstly configure the Epic, right? At that time, I cannot access through the auto band management port because right operating system. Okay, this Epic, if you see this Epic hardware on the Epic, you are getting two ports, which is going to connect the fabric, or you can say connect to leaf. These ports are known as fabric port. There are two ports which is going to connect LAN network. Those are my auto band ports. There is one port which is my console port, and one port is there CIMC port. So currently these two ports are my fabric port. This is my auto band port. Console port is to access this controller through the console. Because firstly, when you purchase the Epic, right now you will get only the ACI operating system. ACI OS will be there, but that is not configured. You have to configure it via the console. Now, what is the use of CIMC port, guys? Anyone who is from the server team, who knows the server? What is the use of CIMC port? Anyone who knows the CIMC?
No, no.
No one? Okay.
Is it a console port?
No, console port is different.
ILO kind of port.
Correct, ILO. Okay, so basically this Epic hardware, if you see the Epic hardware, this Epic hardware is Cisco UCS C series server. C series server hardware. Okay, so if you want to configure with respect to the server, then we are using this CIMC port. For example, we have put multiple hard drive there. If you want to configure RAID, so then we are using this CIMC. Any changes into the hardware, you can use this CIMC port. Or by default, Cisco will put ACI operating system, which you can access through the console. But what will happen if this operating system got crash due to any reason? Then you can log in through the CIMC and you can put a new operating system there also. Clear? Any confusion? Now, so let's suppose you will get a fresh epic now. Now, in the fresh epic, you are going to configure initial configuration. Okay. So firstly, you will connect via the console. When you connect via the console, you will get this initial script. Now, if I give everything in one single, just a second. CI. You will get this initial script when you access through the console. So let's suppose in my environment, I have 4 controllers. Okay. When you are making the cluster, there will be the 3 controller in a cluster. 4th one, I want to take as a standby. Okay. So firstly, you will connect through the Epic one and you are doing this configuration. So when you connect with the console, you will get this initial script. So firstly, it will ask enter the fabric name. You can put any fabric name. Enter the fabric ID. You can define any ID between 1 to 128. Third point is important. Enter the number of active controller in the fabric. Okay, so if you are going to make a controller, if you want to make a cluster, so minimum 3 controller you have to put. Enter the pod ID. You can define it 1. Pod is, you can say, like when all the devices are registered on the controller, then pod you can assume like a grouping of your devices, spine, leaf, and your controller. Okay, so how many devices are registered under this pod ID 1? Is this a standby controller? No. Currently, controller 1 is my active controller. Enter the name of the epic. Let's say I give a epic 1. Enter the address of tap address. So here, this is my tap pool. You have to define any subnet here which is not used in your production environment for the data traffic. So this is the tap pool. Once the devices will be registered on my controller, they will get automatically IP address from this tap pool. and that TAP IP address will be used for VXLAN source and destination TAP IP address. Then you have to define a infra ID. Here you have to put such VLAN ID which is not used into the production environment. So normally we are taking here 3900 any VLAN. Then enter the address pool for the BD multicast addresses. You have to use any multicast range here which is not used into your production environment. So these three things are basically for the VXLAN. Okay, now what is VXLAN? We will discuss after this entire session. Like once I will complete the theoretical portion of day 1, then I will discuss the VXLAN also. So you have to define a tab pool, you have to define a infra VLAN ID, and you have to define a multicast addresses. Then you have to define the configuration for out of band. By default, there is no IP address you are connecting right now through the console. So you have to define the out of band IP address. So any IP address you can define, let's say this. What will be the default gateway? By default, username will be admin on Epic. You have to define the password for that. Once you define the Epic controller, first configuration, okay, it will be the save the configuration and you have to reload the device. Done. Then you will connect same way via the console on the second controller. Everything will be the same. Just enter the controller ID instead of 1, you are putting here 2 now, because this time you are going to configure second controller. What will be the name? Let's say Epic 2. Then this configuration will be common. Then here IP address will be changed. Let's say 45. Rest of the things will be same. Then you are going to connect with the third controller via the console. Epic 3. .46. Rest of the things will be same. Now, when you connect with the fourth one, active controller will be 3. But this time you are changing no to yes here. Because this I'm making fourth controller as a cluster. Fourth, Epic 4, everything will be the same, 47. Okay. When you do all these configuration on controller 1, controller 2, controller 3, and controller 4, these controller 1, 2, 3 will be into one cluster. Okay. For clustering, there is no separate configuration. Automatically, it will form the cluster with controller ID 1, 2, and 3. Fourth will be into the standby. So if one of the controller goes down, automatically it will become the active controller. And once it will be back, again it will be the standby. Clear? Any question, guys?
No.
Okay. This particular point maybe it can be changed. Maybe somewhere you will get 1 to 31. It depends like okay, how many controller is supported on that particular operating system. So current version is 5.x. Okay. Now, so this is what my initial configuration of the controller. Now, as I mentioned, when you are making the cluster, normally if I talk about clustering, minimum 2 devices I needed, right? You can make the cluster of 2 controller. You can make, there is no issue. But let's suppose right now you have made cluster, you have 2 controller, Epic 1, Epic 2, and you make it as a cluster. Okay, so first thing, when you make the cluster, then there is no active standby scenario. both the controllers will be active and both the controllers will have the same configuration. If you connect 1 or 2, it doesn't matter. You will get the same configuration. If you do any configuration changes on controller 1, automatically that changes will be replicated to the controller 2. Now, if you have two controllers and you make the cluster and due to any reason one controller fail, then the single controller will go into the read-only mode where you cannot do the configuration. Clear, guys? That's why it is recommended when you are making a cluster, always put 3 minimum controllers. Any confusion here? Anyone? Why we are taking the 3 controllers?
Can you repeat this point? Hello, not audible. Hello, hello.
Now, I'm audible?
No. Actually, we lost you in between. Can you repeat the point? What was it?
I'm telling, when you are making a cluster of 2 keys, if one controller goes down, then other controller will go into the read-only mode. Okay. That's what controllers into the cluster.
Actually, your voice.
My voice is properly?
Your voice is actually breaking in between. Yeah, it's happening for others
Just give me
also or for me.
if it's happening for all of the service provider, just it will be disconnected for 30 seconds. Guys, now voice is okay?
Yes.
Audible? Just a second, let me connect to the LAN also. Next topic is fabric discovery. Okay. Epic. In our initial discussion, we discussed that thing. Epic can be connected to the Leaf devices only. And one Epic can be connected to maximum 2 Leaf. But when we are connecting with the 2 connections, one of the link will be active and another link is going into the standby mode automatically. Which link will be active and which link will be into the standby mode? That depend on LLDP. So as I mentioned, like, okay, on all the interfaces, LLDP is by default enabled. So once you connect the connection, it will start sending LLDP packet. So on the epic, whatever link will get LLDP acknowledgement first, that will become active and another link is going into the standby mode. Clear, guys? Whatever link will get acknowledgement of LLDP packet first, that particular link is going into the active mode and another link is going into the standby. Fine. Now, so whatever link is active on the epic will discover one leaf. It will discover this leaf. Now, we have to register this leaf. To register this leaf, to register leaf switch, assign node ID and node name. These are the two things you have to define. Once you define node ID and node name, leaf will be registered. Fourth point. Now, leaf will discover directly connected switches. And those switches are what? Spine. Because in the spine and leaf connectivity, leaf can be connected to the spine only. So let's say here I give 101 ID. Leaf 101 discover two spines. Now register these spine by assigning node ID and node name. Then let's say here I give 201, 202. Now spine will discover other connected switches, which will be what? Leaf. Now register those leaves. Okay, this process will be continue until and unless that entire fabric is not discovered, and this is known as what? Fabric discovery. Okay. And this discovery is done through the LLDP packets.
When you are saying now register these leaves, like this will be this will require human intervention or it will be automatic?
Yes, we have to do manually.
Okay.
Fine. This particular process, okay, in your lab, this is already configured. Okay, discovery is not there, but I'm going to show you this thing, the same process. You can assume I have just configured the initial configuration on my controller, and through the out-of-band IP address, I am accessing my controller. So first time when you access, you will get the welcome screen. Okay. What are the new features added to the new version now? So this thing you will get first. Right now, nothing is configured on this fabric. Okay. It is just you have the spine, you have the leaf, and the controller is connected with the leaf devices. That's it. Now, first task we have completed. We have done the initial configuration on our controller, which is already done. Then second step is we have to discover and register our entire ACI fabric on our controller. Because if the devices are not registered on my controller, then the controller will be not able to push the configuration to the devices. Okay. So from here, firstly, you can just click on this fabric membership and it will start discovering the membership step by step. One option is this. Here you can configure the BGP, NTP, DNS, proxy settings. Okay. Right now, I don't want to configure from this option. I just want to do from the actual place. Okay. So there is a tab, fabric tab. Under the fabric tab, there is an option inventory. And under this, there is an option fabric membership. Under this fabric membership, registered node. So right now, if you see here, there is nothing. Okay, when the devices are registered, it will come here in this particular place under the registered node. Under node pending registration, if you see, it discovered one serial number. Okay, port ID 1, you have configured this thing on the controller. Node type is leaf. Okay, there is no node ID and there is no name. Once you give these two things, then this particular device will be registered on the controller and then it will comes under the registered node. For the registration purpose, you have to just right click on this particular entry and you will get an option register. You can define a node ID. Let's say I'm putting node 101. Node, I can define leaf 101 and you can just select register. Here, if you see the status is unknown, in few seconds, it will be coming here. It will get one IP address and the status will be active. Okay, still unknown, not an issue. Some internal communication is going on. This IP address on the epic, you have configured tab pool. Maybe 10.0.0.0/16 they have configured. So from this tab pool, one IP address, it will be allocated to you. Okay, active. So this device is registered on my controller. So if I go to my pending node registration, it is start discovering some more devices. Okay, two more devices are coming and these are what? The spine, because leaf can be connected to the spine only. Same way, right click, you can register. So here I can give node ID 103. Spine 103. registered. Let me log in once again. It is giving some issues. Fabric membership. One node is registered. (103). Spine 103. I can register. 104. Spine 104. They have discovered one more leaf. So this process will be continue until the entire ACI fabric is not discovered.
So can't I automate this process also, like naming and all? Because
No.
this will be a tedious task. Although it will be a one-time activity, but still.
No, we cannot do this automation. So 2 leaf, 2 spine. There is no virtual leaf, there is no virtual spine. These two options will be coming into the picture when you deploy the vPod solution. Okay. So all are active right now. Here under the topology, if I go to my topology, it will fetch the topology how they are connected. Fine. So in this, there are two epic 1, epic 2, which is connected to the leaf 101. And they have connected like this way. Leaf to leaf cannot be connected, spine to spine cannot be connected. If I expand my port 1 here,
Hello.
yeah.
One question here. In this topology, I'm seeing that both the leaf both the epics are connected to one leaf only. What if for redundancy, if that leaf goes down, then
in that case, everything will be down. Like you are not able to push the configuration. So actually, like whatever thing I'm accessing right now, that is a ACI simulator. It is a simulator. Okay, this is not the actual pod. So in your production environment, it will be like this way. Let's suppose I have 3 controllers. Let's suppose. So I'll be connecting like this way. If one leaf goes down, one epic goes down, there will be no issue. Clear?
yeah, clear.
So under the pod, it is showing all the leaf devices right now. If I expand this one, chassis, I will get to know like, okay, what is the chassis, all those things. Under the interface, I can check like, okay, how many interfaces are right now, link is up or down, discovery state is there. Okay, admin down. Yeah. Process and all those things. If I expand this one, so right now it formed the tunnel automatically. You can see tunnel 1, 2, 3, it formed automatically. And this will be my tap IP address. Right now I'm checking with which one? Node 101. Okay. IP address 248 dot something like this. So destination is 10.3. So it is showing like, okay, where to where it will make the tunnel. Same thing I can get from the CLI also. Where it is a putty. Okay, you are on Epic. There's a command show switch. Okay. So this command will display show switches. Maybe there is some issue with this simulator show B management. Okay. Currently, it is showing me auto band management IP addresses show OB management. Show switch command should also run. Okay, where it will give you the information about my all the devices. Okay, right now it is not showing any information about the switches because right now nothing is configured with respect to the switches. If I access my personal board, go to the fabric. Okay, so in this particular rack, I have one spine, two leaf. Okay, these IP addresses are my tap IP addresses. If I go to my interfaces, so you can see some loopbacks are automatically created here. Okay, internally. SVI is there. They are created because some configuration is already there. Can remove the configuration and SVI options will be gone automatically. Okay, nothing. 10.30.27. Is there any configuration still? Maybe it's some internal configuration, but I have deleted all the things. Cool. So this is what my fabric discovery. That will be your first activity. There will be some points in that. Let me just. We will do this discovery number 1 after the lunch, but I'm just explaining what are the things there. Let us do one more thing and then we will reach to the discoveries. We have completed initial configuration of the epic. We have completed the fabric discovery. Then there will be 2 discovery we have to do today. Discovery 1 is my fabric discovery. There will be nothing, just some commands are there. Discovery number 2, you have to configure NTP and auto band management. Okay, so before reaching here, let's discuss our GUI. So when you log in, first tab is your system tab. Okay, so it will give you the information about the system. What is the system health? So it is showing the system health is working fine. All the leaves and spine are healthy. All the controllers are fully fit. There is no issue. Tenant health score, it is not showing right now because right now I haven't created tenant here. Okay, currently I log in with the admin user account. So under the system tab, there are sub tabs are also there. Let's say quick start. So for fabric setup, inventory, okay, creating a tenant. So all those options are there also. So here it is showing like a quick start. Dashboard, this is my dashboard where I will get the system health, any fault is there, fault type, fault by domain. Controller, whatever controller you have, okay? So you will get the detail of this. So right now I have 3 controllers, so it is giving me that thing. If you want to put any controller related policy, you can create from here. System setting, if you want to do any configuration with respect to the whole system, whole fabric, you can do it from here. Smart licensing, if you have the smart Cisco user account, so you can just register your Epic here and it will directly fetch the license from your Cisco smart account. If any fault is coming here, configure zones, any event, it is coming here. Audit logs, it is coming here. So fault, event, audit log, by default, they will store into the controller. If you want to send these information to any third party meaning is that, let's say in your production environment, you have the syslog server. If you have SNMP server, you can redirect those logs there also. Active session, let's suppose if any user is connecting to this controller, it will give you that information. So currently I log in through web and I go log in through the CLI. So that's why it is showing me 2 options here. Now, whenever you are doing the ACI configuration is divided into 2 parts, logical configuration and the physical configuration. So logical configuration you have to do under the tenant and physical configuration you have to do under the fabric tab. Logical configuration is my tenant, physical configuration is my fabric tab. So under the fabric tab, again, there are 2 options, fabric policy and the access policy. If I define the policy for a particular endpoint PC, then I will configure the access policy. If I want to define any policy with respect to my spine and leaf, then I will configure the fabric policy. For example, if I want to configure NTP, NTP is my centralized policy, which should be applied to my all the spine and leaf. Syslog, SNMP. Okay, so if I want to apply these kind of policy, I have to configure what? Fabric policy, which apply throughout the fabric. If any policy with respect to the endpoint, then I will configure the access policies. Clear, guys? Any confusion?
This tenant part, can you explain? Infra management and this thing? The tenant part. This is clear, fabric policy and access policy.
This tenant, I will take it separately. Under the tenant, lots of things are there. Okay. By default, there will be the 3 tenant. Infra is for internal communication between the spine and leaf. There is a default VRF is there. Okay, overlay VRF1. Okay, which is maintained by the infra tenant. Management. If you want to configure with respect to any management related stuff on my fabric, for example, if you want to configure auto band management IP address on your spine and leaf, so that kind of configuration you have to do under the management tenant. Anything which you are configuring with respect to the management of the fabric, then you have to do under the management tenant. Common tenant. If you want to share some common services for multiple tenants. Okay, let's suppose you are a service provider. Okay, now you have different customer. Customer A, customer B, customer C. Okay, they all need the internet. So as a service provider, what you can do, whatever internet is coming, you can put under the common tenant and you can share the common tenant to rest of the customer. So common tenant is basically for sharing the services among different customers. Okay, so basically this is used for the route leaking, you can say. Whatever routes are coming, if I leak the route on multiple customers, so they will get the resources.
Yeah,
Okay,
this route
so
leaking concept is something sort of like, again, I want to give internet connectivity to all these, so that through common tenant I will also provide the route to all the three. Something sort of that,
yes,
correct?
correct. That is known as basically, like, if I go with the technical terms of that topic, shared services. Okay, if time allow, we can discuss that thing on the last day. If time allow, I will show you the lab also, not issue. Okay, then the next tab is my virtual networking tab. Again, in the fabric, I'm not going that much detail right now. I just firstly explain all the tabs, then I will go into detail. Like under the access policy, lots of things we have to discuss. Now, virtual networking. If you want to integrate any kind of virtual environment, for example, OpenShift, OpenStack, Microsoft Hyper-V, Red Hat KVM, VMware ESXi, and VMware SDN. What is that VMware SDN? Anyone is working on this particular product? Anyone?
It's NSX.
NSX. You can do that thing. Then admin tab. Under the admin tab, you can configure AAA, Redis Intaka server. You can put scheduler there. Means, let's say if you want to take the backup at a certain time, you can put the schedule there and then you can call their backup. Firmware tab is if you want to upgrade the firmware. External data collector, for example, like if you want to configure syslog and SNMP. Config rollback, this is for your backup. So by default, the backup will be stored on the Epic. Okay. If you want to forward the backup to any FTP server or SCP server, then you have to choose this option, import and export. Next, operations. Okay, so operation is basically for the troubleshooting task. Okay, I will show you once we done the communication. So here you can create a session, source and destination. Like it will work like a trace route. You can define source and destination, then you can click on submit. It will tell you like, okay, from where to where you are going to communicate. Application, apps. No, as I discussed, like, okay, ACI can be integrate with the multiple products. VMware, okay, you can integrate with the Cisco firewall, you can integrate with the Checkpoint firewall, you can integrate with the F5 load balancer, Citrix load balancer, right? So if you want to manage those products also through the Epic, so you have to add here one, application of that particular product. So for that, you can just go to Google and just give me a second. ACI App Center. Okay, so here there are lots of applications. If I go down for different product, endpoint update, network assurance, FI ACI service center, dashboard, fabric automation. Okay, someone asked that thing like, okay, can we do that automation? I'm not sure, but if this application is there, we can check with this thing. It is telling fabric automation basically. Okay. Let me just download if it need a login access. Okay, I will do that thing later. I will check with this thing. Okay, maybe we can do with this. Let me check that thing. Okay, so these are the applications basically, which you can upload into this Epic, and then you can work on that thing. Okay, so there is an option, let's say downloads. Once you download those application, there will be option upload file to the Epic. So you have to download from the Cisco account, then you have to upload to the Epic. Then it will come here under the install tab. Then you can do that thing. Then you have integration. This integration tab is used for integrating your UCS manager with the ACI fabric. Right? Any confusion in the tabs, guys?
No, it's okay.
Okay, then. Next. Now we are going to discuss the ACI configuration. ACI configuration and ACI terminology. So as I discussed, ACI configuration will be completed in two parts. Physical configuration and logical configuration. Physical configuration can be done by the fabric tab. Right now, I am talking about a particular endpoint. Fabric tab. Under the fabric tab, access policy. And logical configuration is done under the tenant tab. Okay. Good. Physical configuration for endpoints. So there will be lots of terminologies coming. First one is VLAN pool. Second one, domain. Third one, AAEP. Fourth one, interface policies. Fifth one, interface policy group. Sixth one, interface profile. And seventh one, switch profile. Okay. We have to understand these things now one by one. Let's suppose spine leaf 101, leaf 102. And here I have a endpoint 1/1. First thing, in the ACI fabric, firstly, you have to create a VLAN. You have to define a range here, a range of VLANs. One endpoint will use only one VLAN, but we can use the resources for the different kind of configuration, different configuration also. Same VLAN pool can be used in different configuration. So that's what we are defining a range here. So you can define any range. Let's say I define 100 to 200 range. When you are creating a VLAN pool, it will give you the option allocation mode. Under the allocation mode, there are two options. The allocation mode can be static and can be dynamic. You have to choose static option if endpoint connected directly with leaf switch. Like this. This particular PC is directly connected with the endpoint. Dynamic. If endpoint is virtual, or you can say VM. Okay, then you have to choose the option dynamic. Clear this thing, guys?
Yes.
For your reference, okay, I'm recording this session, but if you want to take a screenshot, you can take the screenshot. It will help you in that, like when you are doing the configuration. So first, you have to do, like you have to create the VLAN pool. One more thing, you can, in the ACI, you can do the configuration from here and there. Means in one option, you are creating more, like many options to create other configuration also. Okay, but follow this sequence first. Once you will be expert in the configuration, then you can choose any option. It's up to you. Second option is domain. Okay, domain provide what kind of endpoint you have. Provide connectivity. Not provide, you can say define. Define connectivity with ACI fabric. For example, under this, there will be 4 options. Physical domain, external bridge domain, external routed domain, and FC domain. Okay, let's suppose if I have a PC endpoint connected with leaf, so I will create a physical domain for that. If I'm connecting with a leaf, okay, and here is my endpoint. This is the normal your IO switch. Okay, and if you want to extend your ACI fabric, then you have to configure here external bridge domain. If leaf is connected with a router and router is connected with the external network, then it will be external routed domain. Okay, in the new version, they have renamed this thing external L3 out domain. If you are connecting with any kind of FC domain storage, then here you are creating the FC domain. Clear this option? So whatever domain you will define, you have to associate VLAN pool to domain. Clear? Any confusion in step number 1, step number 2, guys? Any point you want to ask here? All good till now?
Yes.
Third one is AAEP. AAEP is logical unit which contain domains. Okay. One AAEP can contain multiple domain. One AAP can contain multiple domain. Clear? Okay. So till now, we create the VLAN pool, we associate it with the domain, and domain is associated with the AAP right now. Leaf 101 connected with the PC. Now, what kind of configuration you want to do on this particular interface? Okay, so for that you have to do the configuration, and configuration you have to do what? Policies.
Is AEP is a something sort of collection of domains, or
Correct, collection of domains, you can see.
my breeze domain, my external router domain, everything, all the policies or all the information will be containing under this thing, correct?
Collection of domains. Domains meaning is that those 4 which I discussed into previous step: physical domain, then L2 out domain, L3 out domain, FC domain, and one more is there, VMM domain, not the bridge domain. Okay, I will mention that thing. Physical domain, external, bridged and routed domain, FC domain, and there is one more VMM domain for the virtual networking. Okay, not with the bridge domain. Clear? Next, create policy for endpoint link. You want to enable CDP here, what speed you want here, LLDP is enabled or disabled, CDP is enabled or disabled, you want to enable BPDU guard or not. So those kind of thing you can configure under the interface policies. Interface policy group. Now, call all policies in policy group and associate AAEP. So if you focus step number 1 to step number 5, they have the relationship with each other. VLAN pool call into the domain. Domain call into the AEP. In policies call into the group and AEP. Right? So this policy group is having all the previous information, correct? Any confusion, guys? Anyone? Any doubt? Interface profile. Define interface where you want to do configuration. Okay, let's suppose 1/1 and associate policy group. So in the interface profile, I define that thing. Okay, interface is 1/1 and I define the previous group which I have created. But still, one thing is missing. Okay, that where this 1/1 present. Define leaf switch where endpoint connected and associate policy group and associate policy group. Sorry, associate interface profile. Because policy group is already associated with the interface profile, right? So this will be the flow of the configuration, guys. Physical configuration flow. Any confusion? You can ask. Okay. Again, I'm writing this flow in a clear form. Physical, or you can say ACI physical construct. First, VLAN pool. Second one, domain called VLAN pool. Third one, AAEP called domains. Fourth one, interface policies. Fifth one, interface policy group. Call interface policy and AAEP. Sixth, interface profile. Call define interface and call policy group. Seventh, switch profile. Call leaf switch where endpoint connected and associate interface profile. Clear? Any question you want to ask here, guys?
So we'll be doing this in lab.
Yeah, everything like whatever we have written here, we are doing the lab on that. But maybe this particular lab is coming tomorrow, not today. Fine. But I will show you this lab on my rack first, so that when you are performing the lab activity tomorrow, you will get more clarity. Okay. With respect to the lab activity, guys. Just give me a second. So our theoretical portion we have to do. We have